Hello everyone. I am Sridharan, Assistant Professor from the SNS College of Physiotherapy. So in this video, we're going to see about the topic which is basic physics and the working of electricity, which is based on the electrotherapy. So now we're going to see about what is electricity. Generally, this electricity is a flow of electric charge, where the all electric current in our everyday life, the flow of electrons from the negative charge to the positive charge. Each and every electrons that flow in the circuit have been following through the conductors. So some of the conductors, such as the metals like copper, iron. So these kind of metals are the good conductor which conducts electricity more easily and feasibly. Electricity is a form of electric energy that converted light, heat, motion, sound, and etc. These are the general symbols that predominantly used in the electrotherapy. So, symbol Q, which denotes the electric charge, which is SI unit of electric charge is Coulomb. Second, the symbol I, which denotes the current, where the SI unit for the current is ampere, A. And whereas symbol V denotes the voltage, where the SI unit of voltage is volt. And symbol R represents the resistance. The SI unit for the resistance is Ohm. And whereas the symbol P represents the power, which the SI unit of power is watt, W. And finally, energy E, the SI unit for energy is joule, J. Generally, this is the sum of the flowchart diagram, which shows general understanding about the electric charge. So, the definition about the electric charge is the fundamental property causing force in the electromagnetic field. The unit for the electric charge is coulombs. And types, the electric charge is generally divided into two types: positive charge and the negative charges. And the quantization of the charge exists only with the discrete multiples of the elementary charge. The charge and the Coulomb's law. There are two types of charges mainly used in the electrical charge, such as positive charge and negative charge, where the positive charge is nothing but the protons and the negative charges by the electrons. As like each charges, alternative charges may likes each other, and the like charges may repel each others. The Coulomb's law states that the magnitude of force between the 2 point of charges, the electric current, whereas the current I is equal to Q by T. 1 ampere is equal to 1 coulomb of charge passing per second in the metals, whereas the electrons drifted slowly. The conventional current direction positive to the negative flow, actual electron flow from the negative to the positive charge. So this is the smart flow chart which represents the understanding about the electrical current. Whereas the voltage, the potential difference, the energy per unit of charge. 1 volt is equal to 1 joule of energy given to the 1 coulomb of the charge. The batteries and generators create voltage, whereas these voltage have been created by the EMF, which is nothing but the electromotive force. The analogy about the voltage is, whereas the voltage moreover seen in the water pressure, where the current shows the water flow rate and the pipe resistance is the electrical resistance. This is the small example that related to the flow of water, where is compared to the flow of electric current. Now we're going to see about the resistance and the Ohm's law, the most important law which represents the physics. Whereas V is equal to I into R. Here V represents the voltage, I represents the current, and R represents the resistance. So the good conductors have the low resistance, whereas the insulators have the very high resistance. So the good conductors are such as copper and silver, whereas the insulators are rubber, glass. The semiconductors, which moderately conducts the electricity as well as also moderately insulates the electricity. So silicon is one of the major example for the semiconductors. The resistivity and the resistance formula R is equal to pi into L by A. Here, the pi represents the resistivity of the material, whereas L represents the length and A represents the cross-sectional area. The electrical power P is equal to B into I. We are here. It is also represents as the P is equal to I square R. The householding electricity capacity for among the India is 230 volt, whereas in USA it is 120 volts. Example, a 100-watt bulb on the 230 volt draws I is equal to P by V, whereas here P is equal to 100 and whereas V, the resistance is equal to 2 by 30. And here the flow of electrical current, electrical charge per 100-watt bulb is 0.43 ampere. So capacitors are nothing but the instrument which uses to store the charge, whereas the inductor or the materials which opposes the charge in the current, and it also majorly used in the transformers and the electrical motors. Thank you. So we see you on next video in this with discussing the some other topic. Thank you.